Good morning, students. Today again we are ready to learn something new. In this series of learning, now we reach up to the topic where we talked about the capacity and the volume of different objects. In our previous classes, we discussed about surface areas of different shapes like cylinder and cone and cuboid and cube. Now we will discuss about the volume of the object like cylinder and cone. Okay. Now first, just understand what is the volume. Okay, the volume is the measurement of the capacity or the area occupied by a 3D object. Okay, this area occupied by a 3D object is denoted as a capacity or volume. Okay. So we will learn about it. First, I would like to tell you few things about volume. Okay. Now see, the capacity depends on the inner space or the inner area occupied by a distinct object. Okay. Like there are few quantities which you have to memorize. Like in 1 meter cube, there is a 1000 liter capacity. Okay. 1 meter cube area, occupational area, is denoted as 1000 liter. If suppose a cuboidal tank is there, which is 1 meter wide, 1 meter in depth, and 1 meter in length, and that occupies 1 meter cube of total capacity, and it describes as in how much water we can store into it. That will be denoted as 1000 liters. Similarly, in 1 centimeter cube, there is 1 ml, and in 1000 centimeter cube, there is 1000 ml or 1 liter. So this is the few capacities or quantities you need to memorize. Okay. Now let's move on to our topic. First, we will discuss about the volume of a cylinder. What is the volume of a cylinder? Okay, since we all know in a cylinder there is a circular base up to a distinct height. We all know the area of this circular base. Area of this circle will be pi r square, and it is up to h height. So pi r square into h, which gives us pi r square h. That is the formula for volume of the cylinder. Okay, this is how we describe the volume of the cylinder. It is the inner capacity or inner area which can be stored in that cylindrical object. Similarly, in cone, okay, there is a practical approach to find the volume of the cone. Since this cone is having, however we are moving towards the end, its radius reduced, okay, and goes up to 0. So, like this 3 cones, okay, like this 3 cones, you can fill a cylinder, okay, 1, 2, 3, like 3 times you can pour the water taken from this cone to this cylinder. So, we have to put it 3 times, okay, so that we can say that cylindrical volume is 3 times the volume of the cone. Okay, so that's why this cone's volume of cone is 1/3 of cylinder. 1/3 volume of cylinder, and volume of cylinder we all know that is 1 by 3 pi r square. Okay, so this now we can get the formula for volume of cone. Yes, it's easy. Now see few questions based on this. Okay, let's see. A soft drink is available in 2 packs. A tin can with a rectangular base of length 5, 4 and having a height of 15. Okay, so a soft drink company is making 2 types of can, tin can and cylindrical can. Okay, this is very basic question to understand the difference. Okay, in tin can, the base is a rectangular of 5 and 4 and it is having a height of 10 centimeter. Let's see. I have made a tin can. You might have seen in markets Tetra Pak. Tetra Pak is quite rectangular if you have seen. Okay, in this Tetra Pak, the base is 5 and 4 centimeter and height is 15 centimeter. And in other hand, there is a cylindrical can, okay, which is having base radius 7 cm base diameter and height is 10. So diameter is 7 cm and the height is 10. Okay, we need to find that which of the can store more amount of soft drink in it. So we need to find the capacity of both, and we need to find the difference which can be stored more quantity of that cold drink. Okay, let's see. So here we can apply the volume of cuboid formula. As you can see that this shape is cuboid. So volume of cuboid is L into B into H. Okay, length, width and height. So 5, 4 and 15 will be there. 5 4s are 20 and 15 2s are 30. So 300 centimeter cube volume of soft drink it can be stored. Okay, in other hand we have cylindrical can. This cylindrical can having diameter 7, so that it is already known that 3.5 cm will be the radius and the height is 10 cm as mentioned in the question. The capacity or the volume of this cylinder is pi r square h. Pi we can take 22% because r we are having multiple of 7. We can write it as 7 by 2 also if you want to make it easier. So 7 by 2 pi r square h is 10. Okay, now see 7 will get cancelled. From 2 we can cancel this 22 and from 2 this 10 will get cancelled. 11 into 7 5s are 35. If you multiply 385 centimeter cube volume is got. Now see the difference. Okay, it is having more height, it is having less height, but it can store more because it is cylindrical. Okay, cylindrical base can be covered more area than the rectangle. We have seen it before. And here also you can see the same. So we can say that cylindrical can store 85 centimeter cube more than cuboidal or tin can. Cuboidal tin can. Okay. So this is the difference. This is how we can easily compare both the shapes. Okay. Now let's move on to next question. I'm just rubbing it. It is actually, this question is very common question. It is asked so many times. Why it is asked so many times? Because it defines the chapter. It asks you cuboid volume also and comparatively to the cylindrical volume also. So this type of questions are more more comes in question paper. Now let's see next question. The lateral surface area of cylinder is 94.2 centimeters square. LSA of a cylinder is given to us. LSA of cylinder is given 94.2 centimeter cube square, and it says the height of the cylinder is 5. We need to find the radius of the base. Height is 5 centimeter. We need to find radius of the base and the volume of cylinder. Let's see. LSA of cylinder is what? LSA is 2 pi RH. Okay, it is given 94.2. 2 pi, now we can put pi as in decimal because our result is in decimal. So we can put here 3.14. R we don't have. H we have 5 equal to 94.2. Now see. 5 to 2s are 10 and 10 you multiply to this 3.14, we got 31.4 into R equal to 94.2. Now we just transpose it, so R comes 94.2 upon 31.4. As you can see 33 is a 90. Let's see, if we multiply it by 3, so 3 4 is 12, 2 will come, 1 will get 10, 3 1 is 3 1, 4, 3 is a 9. So this 4 will be cut it down 3 times to this number, so that our radius comes 3 centimeter. Okay, so you need to very careful for the calculations. Now see, R we got, first result we got. Now volume we need to find out, which is pi r square h. Okay, see again we are putting 3.14 because we all know that our R and H are not the multiples of 7. So here we are keeping the values 3 square and H is 5. Okay, again we can multiply it by 5 because it is having even ones. So that 5 to the 20, 5 is 5 to 7, 5 3 is 15. This will come 15.70 into 9. Now we multiply it by 9, 9 7 is 63. And then 15 9 is 135. 135 and 6 we have carried. So 141.3 centimeter cube will be the volume of that cylinder. This is the answer for your question. Okay. Now let's see ratio question. What ratio question we will see? Okay, how to do the ratio question, ratio problem. I am just rubbing it. Example 3. Two example already we have seen. Now it comes to example 3. Now in example 3, see what is given to us. It is saying the ratio of the two cylinder, radius of the two cylinder are in ratio 2:3. There are two cylinders, their radius R1 and R2. Ratio is given 2:3, and the height of that cylinders are in ratio 5:3. H1 H2 we can take as a height. Okay, it is as 5:3. So 2:3 is the radius ratio and 5:3 is the height ratio. We need to calculate the ratio of the volumes and ratio of their CSA. Okay. V1, V2 we can assume as a volume. We have to find their ratio, and C1, C2 for the curved surface area. We need to find their ratio too. Now see how to find these ratios. First, R1, R2, H1, H2 we are given. I am writing it as R1 by R2 is given as 2/3. Okay, we can keep this right away like this. H1, H2 also we can keep like this only. 5/3 is given. Now we are first finding the volumes ratio. See, volume is pi R1 square H1 and pi R2 is 2 pi R1 H1 and 2 pi R2 H2. 2 pi will get cancelled with this 2 pi. R1, R2 and H1, H2 we are keeping their values 2/3 and 5/3. This will come 10/9. So the ratio of the volume comes, ratio of the CSA comes 10:9. C1, C2, sorry. Then V1, V2 we will find. V1, V2 is pi R1 square H1 and pi R2 square H2. Pi will get cancelled. R1, R2 square is 2/3 square and H1, H2 is 5/3. This will come 4 5s and 9 3s. This will come as 20/27. So this ratio comes 20:27. Now see, if you can see this carefully, what we can get from it. As you can see, in surface area, the first ratio is bigger than the other. Okay, so in terms wise, in surface area wise, the first cylinder is bigger than the second one. But in capacity wise, as you can see the ratio, the second one is having more capacity than the first one. So sometimes we can't get through the surface area, we can't determine the volume that which cylinder is having much more volume than to other. It doesn't depend on the surface area. So this question denoted that. Okay. Now let's see one more example. Okay, one from the hollow cylinder. So that most of the students have got problem in hollow cylinder because hollow cylinder is quite different. Okay, we'll talk about first its hollow cylinder capacity. So I will explain the formula and the question itself. A cylindrical tube open from both ends is made of metal. The internal diameter of the tube is 10.4 and its length is 25. So here we are talking about the tube. Okay, the internal diameter is 10.4. Okay, and the height which is mentioned in the question is 25 centimeter. The thickness of the metal. Okay, now in previous class we discussed about the thickness. The thickness is the difference between both the radius, greater minus smaller. So that is given to us is 8 mm. Okay, that is 8 mm. We need to find the volume of metal used. What you need to find is volume of metal used to make this system. Now see very carefully. First we need to find the space or the area between these two cylinders, this hollow cylinder. So see, what we can do here is pi capital R square H minus pi small r square H. Why is it? Because from the greater cylinder, when we subtract the volume of the smaller cylinder, we can get the area between both. Okay, so we can take this pi and H common because since they both are equal, so the hollow cylinder's volume will come like this, pi r square minus r square H. Okay, greater r is the greater radius and the smaller is inner radius. Now see what, I am just keeping values here. So pi is, I am putting 22/7 now. Okay, r square minus r square. So I am keeping here as like this only now. The greater r radius is, see, greater radius, how to find the greater radius? 25 centimeter is thickness, right? 25 centimeters, length. Thickness is 8 mm. Okay. So see, 25 is this, 8 mm is the thickness. So 8 mm means r minus r. This thickness is 0.8 centimeter or 8 mm. Okay. So see what I am doing here. See very carefully. R square minus r square H. So what I am doing here is pi. I am applying formula here a square minus b square, which is a plus b minus b. So I am putting here r plus r minus r, and height is 25 cm. Now see, 22/7. Okay, this r minus r thickness, which is 0.8 centimeter, into r plus r. Now r plus r we don't know, we only just know that the radius of the inner cylinder, which is 5.2. So I am just transposing it. So capital will be 8 plus 0.8 plus 5.2. So it will become as 6.0 centimeter. So r plus r is 6.0 plus the inner radius. So 6 plus 5.2 into 25. Okay, like this I am taking here. Let's see now. So 22/7, 8 we can multiply 25 is 200. So this will become 20. This will become 11.2. Okay. From 7 we can cancel it. 7 is 7, 7 6 are 42. It will become 1.6. 1.6 we can multiply it by 20. So it will become 32. 32 2s are 64 and 6. So 704 centimeter cube will be the volume of that hollow cylinder. This is your answer. Okay. What I did here, I just separate the values. You can do differently. What you can do is you can find the capital R value as well and you can put it here. Okay. It is the same value you can got. Okay. But just I made it easier. That's why I did like this. Okay. You can approach it differently. Okay. See, one more reconstitution question we can see. Okay, from a paper, how we can make a cylinder? Okay, how can we make a cylinder from a paper? There is a question based on it. Let's see that question. It says a rectangular sheet of paper is 13/18. See, there is a rectangular sheet which is 30/18. 30 centimeter is length and 18 centimeter is the width. Okay, what it can say now? It says it can be transformed into a CSC of a right circular cylinder in two ways. Either by rolling the paper along with its length, by rolling its grit. Find the ratio of the volumes of two cylinders so formed. See, we can roll it in two ways, from length and from grit. See, there is a quite difference between when we can roll it based on their width and length. Let's see. So when we roll it from its length, what will be the volume? Let's see. See, when we roll it from its base, so this 30 centimeter will become our circumference of the base. Okay, this will become 30. So from there we can find the radius. Circumference will become 2 pi r. Okay, when 2 will get cancelled. So pi r we got 15 centimeter. And h, we have h as 18 centimeter. Now see, here we can find the value of r. Okay, so r value will come as 15 by pi, and 15 by pi will be 7 by 22 because pi is in a denominator. We can keep value as reciprocal. So this will become like 15 7 105 by 22. This will be the radius. Now you can find the volume of first position. This will be pi r square h. Okay. I am keeping here value 22 by 7. R is 15 by pi. Twice I am keeping the value, and h is 18. Now see, 1 pi get cancelled with this pi. 15 square is 225 into 18 upon 22 by 7. So 7 I am writing in numerator because it comes in the denominator of a fraction. So now we can calculate it. Okay. Either you can cancel it by 2. Okay. Now we can't cancel anything else. So I'm just multiplying all of them. 225, 7 side 9 side 63 upon 11. First multiply both. 63 5s is 315. 31 will get carried. 63 2 is 126 and 31. 157. 115 is carried. So for 63 2 is 126 again. 126 and 15 is 141. Now we get cancelled with 11. 11 1s are 11. 3 will carry. 11 2s are 22. 9 will get carried. 11 8s are 88. That again 9 will get carried. 11 8s are 88. 7 will get carried. Okay. 70 6 are 66. 4 will remain. So like this, 1288.60 centimeter cube will be the volume of the cylinder when it rolled from the base of length. Okay. Now again we can roll it from the base 18. So now we are having 2 pi r as 18. Pi r we get 9 and r we will get 9 by pi. Okay. Now volume 2 will come as pi r square means 9 by pi twice h. H is 30 now. Now that 1 pi cancel, 9 9s are 81, pi value is 22 by 7, this pi 7 is come up. Now again we multiply both 11 and 15, we can cancel it already by 2. 15, 7 is 7, 7 is 56 into 15 by 11. Now we can multiply it by 15, 15 7 is 105, 15 6 are 90 and 10 100, 10 carry, 15 5 is 75 and 85 divided by 11. 11 7 is 77, 8 will get carried, again 77, then 3 33, 20 carry, 11 1 is 11 and 11 8 is 88. So we will get our second volume as 773.18. So as you can see, which can be stored more higher capacity of the content of the object. Now see, when we rolled it up to the greater base, okay, it carries more volume. When we rolled up from the smaller base, it can conceive less volume. Okay, let's now see a few questions based on cone's volume. Okay, it is very easy because the formula is bit same. As you can see, it is 1 by 2 pi r square, just 1/3 of the cylinder. Okay, let's see one example of the cone. Beta, for solving this type of question, you need a very keen calculation. Okay, you need to be very good in calculations because there are a lot more decimal numbers to be multiplied and to be cut down. Okay, so you need the sense of the board mass law also and the sense of the solving it betterly. Now see, First, we can see a simple question. Find the volume of a right circular cone of a height 21 and slant height 28. Height 21 and the slant height is 28. So see, for the volume, since the volume of cone is 1 by 3 pi r square h, r is required. We don't need L, slant height. So what we are doing here, we can determine r by applying the formula that L square is r square plus h square. Your L is 28, R we don't know, H is 21. Okay. Now just find the square of 28. That 80 square is 64, 8 2 is 16, 2 is 32, and 6 38. This will be 784. 21 square is 441. We just easily subtract it. It will gives us 3. 8 minus 4 is 4, and 7 minus 4 is 3. 343. Okay. Now 343 actually 7 cube. Okay. So this will come, R will come as 7 root 7 centimeter. Okay. Plus minus. This will be our radius. Now we'll find the volume of cone. Now volume of cone is 1 by 3, pi is 20 by 7, radius is 7 root 7 square, and height we got 21. From this 7 we can cancel this 21, 7 is 21. From this 3 we can cancel this 3 also. Now 22 and 7 root 7 square, which is 7 sevens are 49 into 7. Okay, 49 sevens are, we already have seen, it is 343. Now we will multiply it by 22. 22 3 is 66. 6 will get carried. 22 4 is 88 and 6 94. 9 will get carried. Again 66 and 9 is 75. So 7546 centimeter cube is the volume of that cone. Okay. Thank you. Take care.